Now let us look at the combinational logic gates in detail. Simple inverter, okay, its input, let's say x, output y, then we construct a truth table to depict this functionality. It's if the input is 0, output is 1, if input is 1, output is 0, the Boolean function it realizes y equals x bar. And its logic circuit symbol is this, like a triangle with a circle, like we call it a bubble in digital logic area. We call it a bubble, triangle with a bubble, and input output gate, and this is symbol, and please remember it, practice to draw this. Okay. Then simple NAND gate, its truth table we can depict at this: 0 0 is 1, 0 1 is 1, 1 0 is 1, 1 1 is 0. With Boolean function it implements is A and B whole bar. And its logic circuit symbol, again please practice this, is like this with a bubble with input A, B and output Y. Please practice drawing this symbol. And simple NOR gate is a similar thing with truth table: 0 0 as 1, 0 1 is 0, 1 0 is 0 and 1 1 is 0. Function it realize A or B whole bar. Logic circuit symbol, please look at this and practice to draw. Now, how can we do the fundamental logics out of this? As I was telling, if you run the output of a NAND gate through an inverter, we get an AND. So just see, like by identity we can write. So this first gate is implementing AB bar, means AB whole bar, and then it is doing another inversion on top of that. They will cancel each other. Your function is AB. Similar with a NOR, OR. Like you output of a NOR run through an inverter, and the output of that inverter become a OR logic. And we draw the logic circuit. We has provided the logic circuit symbol for them. We don't usually draw it like these two get, just to compact the circuit diagram. But you can think that a NOR gate, if you see a NAND gate, you know that inside it is basically a NAND gate driving a NOT gate or inverter gate, right? But please practice these symbols: logic circuit for the AND, logic circuit for the OR. I have different implementation for as well, OR as well. So here A and B are inverted first and run through an NAND. So A invert, B invert, whole invert, and by De Morgan it is A or B, right? So we have two different configuration. Either we can use a OR with one inverter or NAND with two inverter at the input side. Some more logic which has symbols. So all the symbols, please do practice drawing. Like if I want you to draw symbol for this, symbol for that, you should just draw it like nicely, beautifully on exam paper. And later we'll see we need to draw the schematic diagram of our logic circuits, and there you will need to put multiple such different logic gates and connect them as the function says. Anyway, so XOR is essentially XY bar or X bar Y. So you can imagine we can combine AND with inversion, AND with inversion, and join them together with the OR. That becomes essentially a NOR circuit. So its truth table looks like this: 0 0 0, 0 1 1, 1 0 1, and 1 1 0. That's XOR, and similarly we can have XNOR, which is basically inversion of this other this function XY bar or X bar Y. Or by definition of the inverse function, you can say it is an XY or X bar Y. So it's not in the slide, please note. XNOR Z is either you can write it like XY bar or X bar Y whole bar, or you can write by the definition of inverse function or complement function, that is XY or X bar Y bar. That's XNOR.